so we talked about doing chain rule problems. How do you recognize a problem that needs the chain rule? Well, it's a composite function, and composite functions have inside parts and outside parts, right? So the inside of this composite function is 3x squared minus 2 over 2x plus 3. That's the best I would pick there. And can we take the derivative of the inside? We can. It's the quotient rule, right? The outside of this particular composite function is a power function. It's just raised to the third power. So remember, the rule is you take the derivative of the outside, rewrite the inside, times the derivative of the inside. So let's see if we can pull that off here. This particular function, g of x, doesn't need any rewriting. It's in a good form right now. So here we go. We have g primed of x is equal to, now the outside function is the exponent, the 3. So when you take the derivative of a power, right, you pull it in front, then you rewrite the inside exactly as is. So that's 3x squared minus 2 over 2x plus 3. So remember, when you're writing the inside, you are not taking the derivative yet. Don't forget to reduce that exponent by 1, just the power rule, times the derivative of the inside. Notice the brackets, because I have to use the quotient rule. What's the quotient rule? Low d high minus high d low over low squared. So low is 2x plus 3. The derivative of the high, 3x squared minus 2, that derivative, use the power rule, move the 2 in front, that's 6x minus 0, which of course is just 6x. So again, low d high minus high, which is 3x squared minus 2 d low. So what's the derivative of the denominator? It's going to be, for 2x, it's just 2, and then the derivative, of course, of 3 is 0 over, don't forget, the denominator squared, so 2x plus 3 squared. Now, don't let this third on the outside throw you off when you're taking the derivative of the inside. So I'm ignoring all that when I use the quotient rule over here. Now, that's the easy part, right? Taking the derivative is the easy part. It's simplifying it that can be a little bit challenging. So let's see what we can do. Now, what I'm going to do is focus over here on the parentheses. I'm trying to see if there's any greatest common factor in the numerator up here. You got a factor of 2x plus 3, a factor of 6x, a factor of 3x squared, a factor of 2. They do have a common factor of 2, but you could get away with just distributing the 6x inside and the 2 inside here, or negative 2, and combine like terms. So let's do that. Had you factored out that greatest common factor of 2, that would have been fine as well. So that's 3x squared minus 2 in the numerator, 2x plus 3 in the denominator, all to the second power, times, okay, so again, 6x times 2x is 12x squared. 6x times 3 is 18x. Over here, negative 2, so this negative times this 2. Negative 2 times 3x squared is negative 6x squared. And negative 2 times negative 2 is plus 4. And that's all over our denominator squared down there. And there we are. Okay, now I want to continue by simplifying this numerator right here. So I'm rewriting the first two factors there, 3 times 3x squared minus 2 over 2x plus 3 all squared, times 12x squared minus 6x squared is 6x squared, 18x is just as 18x, and then plus 4. So notice there's a greatest common factor there of 2. That could be factored out. What if we do factor that out? Okay, that would give me g primed of x is equal to, now if I factor a 2 out of here, I can just bring it right out front, right? So if I pull that 2 out times that 3, that's going to give me 6. Okay, and watch this too, because look, I have 2x plus 3's on the bottom of both of these, so I'm going to write this fraction as each individual one of these divisors squared. So this is going to be 3x squared minus 2 squared over 2x plus 3 squared. Why am I doing that? You'll see in a minute if you don't already know. Now, don't forget, we factored a 2 out of here. We pulled it in front and multiplied it by that 3. So that's going to leave me with 3x squared plus 18 divided by 2 is 9x plus 4 divided by 2 is plus 2 over 2x plus 3 squared. One more line. I'm going to write this in black because this is my final answer. Okay? Now, look at this denominator. I have a 2x plus 3 squared here, and I have a 2x plus 3 squared here as well. So I could write this as 6 times 3x squared minus 2 squared times 3x squared plus 9x plus 2, all in the numerator, over the denominator of 2x plus 3 to the 4th power, because it was the same base, so I added the exponents. How do you feel about that? Lots of algebra, but unlike some of the problems we did in the last video, we're not trying to factor out a square root, which can be really confusing, but simplifying. It's not the calculus, it's the algebra that gets really sticky. All right, well, what about trig functions? Do you see the inside and the outside here? Differentiate, so we're supposed to find the derivative of sine of pi x. So the inside is going to be your pi x, and the outside is your sine. So remember, the first thing you do is take the derivative of the outside. So y primed equals the derivative of sine, we know is cosine. You rewrite the inside, which is pi x, times the derivative of the inside. Now, pi is just a constant, right? It's about 3.14, but it is a constant. So when I take the derivative of pi times x, the derivative, constant multiple you just bring over is pi, and the derivative of x is 1. So I get y primed is equal to, now, these constant multiples are better living in the front of the function, so this is pi cosine of pi x. And that's the final result. Then I threw another one over here just for practice. Hey, why don't you pause it and do that one yourself? So know you're back, I know you got it right. So f primed of x. Again, the outside function in this case is cosine. The inside function is 2x. So you take the derivative of the outside function first, which is going to be negative sine. You rewrite the inside as is, times the derivative of 2x is 2. Now again, simplifying, it is better if you have any constant multiples in the front of the function. So it's going to be, the negative's already there, negative 2 sine of 2x, and that is the derivative. So what about this problem? You want to pause it, try it, see how it goes. All right, so what's the inside? What's the outside? What in the world is being squared? Can you tell what's going on here? Now the square. We know cosine is not squared. Why? Because it's this is what it would look like if the cosine was squared. It would be cosine squared of 1 minus 2x. That is not what we have going on here. Okay? What's squared is the 1 minus 2x that's inside the cosine. You could think about it like that, which means the inside function is the 1 minus 2x all squared, and the outside function is cosine. You ready to jump into this then? So I have y primed equals the derivative of the outside. What's the derivative of cosine? You know it. It's negative sine. You rewrite the inside exactly the way it is, 1 minus 2x squared. Now we're doing the derivative of the inside. Now how do I take the derivative of 1 minus 2x squared? Chain rule, you say? Yep. So I've got to use the chain rule twice in this problem. So when I use the chain rule on 1 minus 2x squared, I'm using the power rule. I move the 2 in front. So that's 2. I rewrite the inside, 1 minus 2x, reduce that power by 1. Don't forget, times the derivative of the inside. What's the derivative of 1 minus 2x? Well, it's 0 minus 2, so just negative 2. Wow, right? So the derivative of the outside function is negative sine. You rewrite the inside. all of this is the derivative of the inside, which is the chain rule again. So 2 comes in front, you rewrite the inside, 1 minus 2x, you reduce that power by 1 times the derivative of the inside. That's a fun problem, isn't it? Now, how do you write your final answer? Okay, now here's a couple of things that I see. This negative right here times this negative right here, gone. This 2 times this 2, that's going to be 4. Let me find my purple again. There we go. So I have y primed is equal to, so again, this 2 times this 2 is 4. And then I'm going to go ahead and put that 1 minus 2x in the front, because it just feels better when trig functions are living in the back when you have multiple factors. And that looks better. You wouldn't be wrong to say sine of 1 minus 2x squared, and then the 1 minus 2x in parentheses in the back. You got to put the 4 somewhere. But it really is more of a habit for people to always put trig factors in the back of your list. And so that's what I always try to do. And that usually matches what the book says as well. Okay, 2 more slides for you, and then we'll wrap this video up. So I've got differentiate cosine of v over cosecant of v. Don't let the v bother you. It wouldn't be any different if there were an x there. But you will see v's and w's, all kinds of variables used. So it's good to get in the habit of seeing other variables. Now, how are we going to do this? We need to use the quotient rule, right? That would work. I mean, we've got a cosine. We know how to take the derivative of that. We've got a cosecant. We know how to take the derivative of that. It makes me wonder why this particular problem is even in the chain rule section. But honestly, it did show up in the chain rule section, and I like it because it makes you go back and think about the best way to just find any derivative, not just chain rule problems. Now, here's something else you can think about too. You know, we prefer sine and cosine functions far more than we prefer tangent, cotangent, secant, cosecant, especially secant, cosecant. We could rewrite this, right? You would not be wrong to jump in right now and use the quotient rule, but you'd probably be happier if you do this. Cosecant of v, watch this. This is y is equal to cosine of v is living in the numerator. Cosecant of v, I'm going to write as 1 over the sine of v, which is equal to the cosine of v. What do I do with this? Flip him, right? Times the sine of v. Isn't that better? And then we could take the derivative just using the product rule. There's still no chain rule happening right here. This is just product rule. So we do, remember, first times the derivative of the second. So this dude is our first. This guy over here is our second. So we do first cosine of v times the derivative of the second. What's the derivative of sine of v? Cosine of v. And then plus the second, which is sine of v, times the derivative of the first, which is negative sine of v. So I have y primed is equal to cosine of v times cosine of v is cosine squared of v. This positive times this negative is negative, and then sine of v times sine of v is sine squared of v. And that's a perfectly reasonable answer. And again, I like this problem. It certainly doesn't have anything to do with the chain rule, but it has everything to do with looking at a problem and figuring out what method you're going to use to take the derivative. And sometimes there's more than one way to get there. So this is the last slide I had for you. I want you to compare the following, because look, it's the same stuff. You got a sine, you got a 5, you got an x, and you've got an exponent of 2. But this is 4 different problems. They're completely different. And so I wanted you to see the difference between these and really notice what this notation is saying. So for example, the sine of 5x squared, another way to write that would be this. Okay? They don't always include parentheses after what you're taking the trig function of, but if they're not there, then you got to assume it's of all of it, unless there's addition and subtraction, and then that wouldn't include it. I like to put parentheses there because it makes me feel better about what is being expressed as my function. But now how do we do this derivative? How do we take this derivative? you've got an inside and an outside, right? Your inside function is 5x squared. Your outside function is the sine. Therefore, the chain rule is required. So y primed, the derivative of the outside of sine is cosine. You rewrite the inside exactly as it is, times the derivative of the inside. Y'all know the derivative of 5x squared is 10x. You've done that enough. And when I rewrite that, again, we like our constant multiple in front of our trig function, so 10x cosine of 5x squared, where the parentheses around the 5x squared are not required, but definitely desired. Okay, now let's look at our next function. Now all I did was throw some parentheses in there. The order of your sine, your 5, and your x squared is all the same, but this means something completely different. Sine of 5 is a scalar multiple. That's just a number you could type in your calculator. I'm not saying do that, because sine of 5 is more accurate. You would have to round it. But that's just a constant. So when I'm taking the derivative, I'm really jumping in, rewriting my constant, and the derivative of x squared, you know how to do that, is 2x. And that's it. No product rule, no chain rule, nothing. That's just a constant multiple and a power function where you use the power rule. Now, it would look a little better maybe if that 2 is in front. And also in this situation, you don't want to put the sine in the back because it's not a function. It's just a number. Sine of 5 is just a number you type in your calculator and you're done. Weird problem, I know, but that's all there is to it. So what's up here, number 3? Sine of 5x squared. Isn't that just like the first one? It's not, right? Because this entire 5x is squared. And there's 2 ways you can handle this, okay? You could go ahead and simplify 5x squared. So that would be y is equal to sine, what is 5x squared? Well, it's 25x squared. And then take the derivative of that. I'm going to do right underneath y primed equals chain rule, right? Derivative of sine is cosine. You rewrite the inside times the derivative of the inside, which is going to be 2 times 25 is 50x to the first. If I rewrite that, the 50x should live in front of your trig function. Okay, that's it. Now, what if you didn't think to do, to square the 5x? What if you didn't think to do that? Okay, then, my computer, then we could think about this as the chain rule twice, right? More confusing, but let's try it. So y primed, again, the outside function is sine, so it's cosine. You rewrite the inside, which is 5x with the square on the outside, times the derivative of the inside. Now, the derivative of the inside is this guy right here, 5x squared. That's what I'm taking the derivative of, which is 2, rewrite the inside, reduce that by 1, times the derivative of the inside is 5. This is one of those where you have to use the chain rule twice. But now, look, when we simplify it, it's y primed equals. Now, when you multiply all this out, I have 2 times 5 times x times 5. So 2 times 5 is 10 times 5 is 50x. Goes in the front, and then cosine of 5x squared remains underneath. So I have the same thing. And of course, we know the 5x squared is 25x squared. So these are the same derivative. They look a little bit different. The method is different. But I say when you can simplify a function pretty easily beforehand, you should. Now, finally, our very last problem in the chain rule section. This guy needs to be rethought. Okay, I'm going to rewrite him down here. This is y equals, not the derivative, just rewriting. Sine squared of 5x is the same as saying sine of 5x squared. Okay, so when the square is in between your trig function designation and what you're taking the sign of, then really the square is on the outside. And when you take the derivative, this is a better look that I have in purple here than my original problem, because the outside function is the square. So you have y primed is equal to, I'm going to handle that exponent, 2, rewrite the inside, sine of 5x, times the derivative of the inside. Now, once again, for the third time, we have to use the chain rule twice. So when I take the derivative of sine of 5x, that's going to be cosine of 5x times the derivative of the inside of that, which is 5. There's a lot going on there. Pause it. Make sure you understand that. So, and there was no really rewriting that function, so you could avoid using the chain rule twice in that case. You have to. There's no choice. So let's simplify. Okay, so again, recap. Derivative of the outside, which is the square. So I pulled the 2 in front. That gave me this. I rewrote the inside, reduced that exponent by 1. Now I'm working on taking the derivative of sine of 5x, which has an inside and an outside of its own. So the derivative of the inside is cosine. I rewrite the 5x times the derivative of 5x is 5. Okay. Now what I do have here is constant multiples. I have a 2 and a 5 at the end. I'm going to say that's 10. And then times the sine of 5x times the cosine of 5x. And that doesn't get any better looking than that. That's as simple as that gets. All right. I hope you have some skills. You're ready to try the homework. Let me know if you have any questions about the chain rule or any of these differentiation rules.